Good morning, my dear students. I hope all of you are safe after celebrating the Festival of Light. Hope you enjoyed the Deepavali holidays also. So once again, we are coming back to our routine work. Since the government has postponed the reopening of the schools, we have to continue the video recorded or our online classes. So today we are going to complete the second lesson. Tomorrow we will be starting the fourth lesson. We'll skip the third lesson. We'll come back to that afterwards. Right? So in the last class we were discussing about the silicates. So about silicates only today's topic is also. Right? So in the last class we discussed about the pyrosilicates and the orthosilicates, cyclic silicates. Those are the three silicates which we have done. Today we are going to do few more silicates. The next type of silicates that we are going to take up is chain silicates. So chain silicates are also referred as pyroxenes. And their molecular formula is SiO3 N2 minus. Right? So in this, the silicate units will be connected like this. We know how to write one silicate unit. It will be like this. One in the middle and three in three corners of the triangle. Right? Rather, this is the tetrahedral position. Right? This is actually behind the board. Here we have the silicon. Right? So this is SiO4 unit. And this is being linked like this. And the next is SiO4 unit will be like this. Right? So silicon will be here. 1, 2, 3, 4 oxygen. Right? And the negative charge will be here and here. Right? And the next one will be like this. Right? We have minus here and minus here. And the next one will go in the other direction. We have silicon here. And this continues. Right? So these type of silicates are being called as the chain silicates. So chain silicates, or this, for the example, we have spodumene. So spodumene is the type of chain silicate which has got lithium and aluminum holding SiO3 units in double number. So that's about the chain silicates. And the next type of silicates that we are taking up is double chain silicates. Right? Next what we are going to take up is double chain silicates. So in the double chain silicates, right, they are being called as amiboles. Right? This is the commercial name given for this. The molecular formula of this is going like this: Si4O11 and 6N minus is the Si4O11 N 6N minus is the double silicate. The best example for this is given as asbestos. Asbestos, which we see the sheets everywhere, no? So they are actually double chain silicates. So in this double chain silicates, so how to draw this double chain silicates? It is almost having one hexagonal ring. Connected like this. Right? We have silicates. The Si4 units are like this. Right? And we have one more SiO4 unit here. And we have one more Si4 unit here. And we have one more SiO4 unit here. Right? And we have one more SiO4 unit here. And it continues here again. So each tetrahedral unit is being shared by two oxygen. Two oxygens will be sharing this. Right? Actually, this is one chain silicate, this is another chain silicate, right? So double chain silicate. So in the half pathomna mala single chain silicate varum. In the half pathomna keela it is another single chain silicate. So when you connect these two, you get this. All these oxygens will have charge. The terminal oxygens will have the charge. Right? So if you take each silicate, so in each silicate two oxygen atoms are being shared, and this is how it is being developed in the double chain silicates, and the best example is the asbestos. So asbestos is a cryogenic silicate. Cryogenic means it's a poisonous. That's why nowadays they don't encourage schools, hospitals should not be constructed by asbestos sheets, right? And the next type of silicate is called sheet silicate. So sheet silicates are also referred as phyllosilicates. They are referred as phyllosilicates. So in this, 3 oxygen atoms will be shared. Or shared in each SiO4 units, right? And its molecular formula is given as Si2O5 N 2N minus. The best example for this is talc and mica, or the example for the sheet silicates. So here again, almost we have the same type of hexagonal shape, right? So this is 1, this is 2, and it goes like this. So you have to put 3 oxygens and 1 oxygen in the middle, and this continues. The same structure we are drawing. Right? So these are the oxygen positions. We have 1 on top. Right? And here we have 1. And here we have 1. So these are all silicates, SiO4 units, right? what we have drawn under the previous type of silicotes, that is double chain silicate. Now this continues. After this continues here. And here again, once more. Here again, once more. Right? Now you have to put the oxygen, the tetrahedral units. What here? Here. Right? This can be continued one more step also. So next step you can put 4. 1, 2, 3, 4. Like that it will keep, then next will be 5. Like that it will be keep on going, and this type of silicates are being called as sheet silicates. And the last type of silicates are the tectosilicates. So last type of silicates is tectosilicates. So tectosilicates are having the general molecular formula as SiO2 N times. Here in the SiO4 4 minus, all 4 oxygen atoms are shared, and it will bring out a 3-dimensional structure. Right? That is the important aspect of this tectosilicates. It's a 3-dimensional structure, whereas the other silicates that we have already discussed is only 2-dimensional. In this, all the 4 oxygen atoms will be shared with the other tetrahedral units. And as far as this is concerned, we have 2 very important examples. One is feldspar, the other one is zeolite. Zeolites. So in this silicate units are replaced by aluminate units. Right? Therefore, it is aluminosilicates. When you say tectosilicates, mostly the type of silicate is aluminosilicates, and particularly we have zeolites. Zeolites are sodium aluminum silicates. They have the molecular formula as NaO, Al2O3, then X silicon dioxide, Y water molecule. Right? This X can be from 2 to 10, Y can be 2 to 6. Right? The numbers. Right? So this is the molecular formula for zeolite. Zeolite is an interesting silicate. It has got porous bonds, small holes here and there, which can accommodate the sodium ions as well as the water molecules. So chinna holes irukkum because it is a honeycomb structure. So then kudu mari irukkum. So then kudu anga chinna water irukkum pathina. And water la vande Na+ poi ottikom, H2O ottikom. Water can easily flow in and flow out. That's why these zeolites are used in hot water conversion to soft water. Right? that we have studied in +1 itself. How to convert hard water into soft water. For that, one of the technique that is used is zeolite. Zeolite is the one which removes the hardening of the water. That is the main application of this zeolites. Therefore, it's always better to have some knowledge about the zeolites also, right? So these are the different varieties of silicates that we have in this lesson. In this, we are closing down this lesson, right? So after that, there is one more division of pre-block, that is third lesson, which we'll take after some time. Then tomorrow we'll go to the fourth lesson, that is about transition and inner transition elements, which will be slightly easier. We'll finish that lesson, then we'll finish fifth lesson. After that, we'll come to third lesson. Take care. God bless you.